Welcome to Module 5. In this module, you will learn about risk assessments, climate change adaptation, and disaster risk reduction. By the end of this module, you will be able to understand risk assessments, how the results of a risk assessment can inform decision making, different adaptation strategies for infrastructure, and anticipatory action as a strategy for disaster risk reduction. Module 5.1 will cover what is a climate risk assessment. First, let's begin with what is risk. We may think about risk as a situation involving the potential for harmful or really bad consequences. Risk incorporates the likelihood or probability of these consequences happening. For example, driving without a seatbelt could be a risk to your health and safety if you get into an accident. Your perspective of driving would be different if you got into an accident every single time you drove. So it's also important to understand how likely these events are to happen and what you can do to reduce your risk, for example, driving carefully or wearing a seatbelt. There are many definitions of risk that exist. Commonly, risk has two themes that we think about, as I mentioned in the previous slide: likelihood and consequence. When we think about likelihood, we may consider how likely is it that something will happen. This is determined by considering the hazard and our exposure to the hazard. When we think of consequence, we may consider what are the consequences if it does happen. This is determined by vulnerability. We combine hazard, exposure, and vulnerability to get risk. Let's take a closer look at likelihood. As seen on the previous slide, likelihood is broken into two parts: hazard and exposure. Hazard is an event that may have a negative impact on societies and the human environment and includes things such as a wildfire, intense rain event, flood, extreme storm, etc. In the case of risk assessments, hazard is the chance of experiencing a certain intensity event at a specific location. For example, at this location, there is a high chance of 500 millimeters of rain falling in 24 hours. That would be a hazard. Exposure, on the other hand, is what exists at that specific location that could be exposed to the hazard. Exposure can consider the exposure of people to a hazard, the exposure of a physical piece of infrastructure to a hazard, or even the exposure of an entire system to a hazard. When we put the two together, we can ask ourselves, how likely is it that a community or a particular piece of infrastructure will experience or be exposed to a particular hazard? Why does exposure matter? Well, if there is a climate hazard that occurs, but there is no exposure or no infrastructure that is in the way or could experience harm from the hazard, then there is no risk. Now let's look at consequence and recall consequences, thinking about what are the consequences if the event does happen. Consequence is largely determined by vulnerability. Vulnerability is the consideration of how sensitive or susceptible something is to damage or harm. Things that are very sensitive to damage or harm are considered to be very vulnerable, whereas things that are less sensitive to damage or harm are considered to be less vulnerable. For example, people who are elderly, children, pregnant, or disabled may be more susceptible to harm in the event of a flood where it is hard to get around. A community may be more susceptible to harm if the government system doesn't have plans in place to respond quickly to a disaster event. A road or house that hasn't been maintained properly or that is old may be more susceptible to damage if it can't handle the strain from climate hazard events. Why does vulnerability matter? Well, if the climate hazard occurs where there is a community, but the community, infrastructure, systems, and people are resilient, then vulnerability to a climate hazard event can be very low. However, if the same climate hazard occurs, where the community, infrastructure, systems, and people are susceptible to harm, then vulnerability to the same climate hazard can be very high. Let's compare risk profiles of two different communities, Community A and Community B, that both experience the same climate hazard event, an extreme rainfall event where 100 millimeters of rain falls in 24 hours. So let's start with hazard, and recall hazard is the chance of experiencing a certain intensity event at a specific location. Community A on the left has a small chance of the climate hazard occurring. Community B on the right has a very high chance of this climate event occurring. This is because they are in different physical locations, and already Community B has a higher potential for risk than Community A. Now let's move into exposure, which, as we recall, is considering what exists at a specific location that could be exposed to the hazard. So let's say Community A has a hydropower dam that provides power to half of the country, and a community that is located on a steep hill with little vegetation. Community A also has a hospital that has the only emergency room in the country and that is located next to a large river. Community B, on the other hand, has no critical infrastructure. It has a community that is located on a high vegetated plateau that is far from the nearest river. And we can see by comparing these two that even though Community A has a small chance of a climate hazard event occurring, if the event did occur, it would be more exposed to the hazard than Community B. Now let's consider the final component of risk, which is vulnerability. And as we recall, vulnerability is how sensitive or susceptible something is to damage or harm. So Community A has a larger aging population, a lot of old infrastructure that hasn't been properly maintained, including the dam, one road in and out of the community, and a newer workforce that doesn't have a lot of experience with repairing infrastructure or responding to emergencies. This community would have a high vulnerability because the aging population may not be able to get around if a flood event occurs, especially since this community is located next to a large river. Additionally, the dam, which is a primary source of electricity for a lot of the country, hasn't been properly maintained and could fail with too much rain, causing impacts downstream. If an evacuation needed to take place, the newer workforce who isn't experienced in responding to emergencies will not be able to efficiently evacuate the community, and if one road that goes in and out of the community is blocked, the entire community will be stuck. So all of these factors are resulting in a very high vulnerability for Community A. Community B, on the other hand, has a large population with quite a few elderly folks that have family support and can help them evacuate in the event of extreme rainfall. In Community B, the infrastructure is older, but it's been properly maintained and inspected over time, so the chance that a road or bridge would fail is very small. However, if the infrastructure did fail, the workforce responsible for repairing infrastructure and responding to emergencies have been well trained and have mentors with experience in their fields, so they would be able to manage and evacuate the community quickly and efficiently. In the event that one of the roads in and out of the community is blocked, there are others that could be used so that the community will still be able to evacuate. In this scenario, we can see Community B has a low vulnerability. Now let's look at the full picture. When comparing the two communities, even though Community A has a small chance of the extreme rainfall event occurring, it is very exposed and has a high vulnerability, which means overall it has a higher risk than Community B, which has a high chance of the event occurring, but it is not very exposed and has low vulnerability. We may say that Community B is resilient to this climate event. This graph is highlighting historical and future risk profiles for different locations in Suriname. So let's start with hazards. Historically, Paramaribo and Wanika face the most climate hazards, and Nikiri face the least. In the future, Nikiri will remain the region with the least hazards, and Sipaliwini will join Paramaribo and Wanika as the regions with the most hazards. For exposure, for both historical and future time periods, Kamawena and Paramaribo are the most exposed due to their exposed agriculture, water, and forestry sectors, as well as their infrastructure. Brokopondo is the least exposed, and this remains the same for, again, historical and future time periods. For vulnerability, Sipaliwini and Brokopondo are the most vulnerable due to vulnerable agriculture and infrastructure. Koroni is the least vulnerable, and this remains the same through both the historical and future time periods. So if we combine all these into final risk in the top section here, we can see that Paramaribo, Sipaliwini, and Wanika are the most at risk, whereas Koroni and Nikiri are the least at risk. The highest risks remain the same for the future time period. So how do we determine risk? A climate change risk assessment is a process of identifying how systems would respond to and recover from the impacts of different climate hazards. A risk assessment will help us understand which climate hazards may pose risks or opportunities now or in the future. This is important so that we can plan for adaptation and build resilience. A climate change risk assessment, or CCRA, usually involves 5 steps. Step 1 is establish the context. So in this step, we set the geographic scope, so we determine what location or region we're going to look at, the time horizons, including the future time period, and we determine which climate variables are most relevant for our assessment. Step 2 is vulnerability and risk identification. In this step, we begin to identify potential climate impacts that we would like to evaluate in the risk assessment, potentially based on previous experience. Step 3 is risk analysis. So in this step, we analyze how likely it is that the climate impact will occur. Recall, this is likelihood. And we also assess if the impact does occur, what are the consequences? So that's the consequence portion. Step 4 is risk evaluation. So we've calculated our risk, and at this stage we prioritize the risks based on their risk scores. And finally, step 5 is adaptation planning. So once we know what the highest risks are, we can determine the most appropriate adaptation planning and implementation to help minimize the risk to people, infrastructure, and systems. How is a climate change risk assessment different than other risk assessments? Well, a CCRA considers the impacts of climate change on the frequency and intensity of current risks. It considers slow onset or gradual climate risks and opportunities, not solely hazard events that lead to emergencies. And it considers longer time horizons, so risks out to the 2050s or even longer, not just immediate or current threats. Climate change risk assessments also consider non-climate stressors, including sensitivity of individuals or communities, and their ability to cope to the impacts of climate change. We might call this adaptive capacity. So this knowledge is integrated into vulnerability and helps determine the consequence and overall risk that communities or people would experience to climate change. To reiterate, a risk assessment is a formal and systematic process of estimating the level of risk, and it considers all the concepts that we just explored, so likelihood of the hazard and exposure, vulnerability, and consequence. Overall, risk assessments can help us understand the potential risks and help us answer questions such as what level of risk are we dealing with, which hazards present the highest risk, and how might the risk change if we introduce ways to mitigate, manage, or reduce the highest risks. Risk assessments won't tell us exactly what to do or how to reduce risk, but they can be a good starting point to make informed decisions about adaptation. Risk assessments can also help us understand the following questions. How much risk can we deal with? Who or what is more vulnerable to risk? Can we decrease any of the risks by implementing adaptation strategies? Where should we allocate resources to minimize risks? Which adaptation strategies are most cost-effective and beneficial? Where do we need communities to be involved in the decision-making? And when should we consider co-benefits?